in this example, we have three equations that represent projectile motion, and we're going to use this generic equation in order to pull out the initial velocity of the scenario, the initial height, and then write a new equation if you double the velocity. So in this first equation, negative 16t squared plus 75t, this represents a toy rocket being launched from the ground. So the initial velocity, you always look at the number in the very front of the middle term because that is your initial velocity there. The middle term has the t attached to it. So the initial velocity then is 75 feet per second. And then the initial height is always your very last term with no variable attached. And so there is no last term here. So that means the initial height is 0 because it was launched from the ground. And lastly, we're going to write the equation if we double the initial velocity. So essentially all you're doing is taking this number and doubling it. So if you multiply that by 2, you get 150. So my final equation here would be negative 16t squared plus 150t. For this next scenario, we have an object being thrown off a building. So the initial velocity, again, looking at your middle term, the number in the front of the t is 48, so 48 feet per second. The initial height, so it's being thrown off a building, so there is initial height here, it's 160 feet. And then the equation, if you double the velocity, so all we're doing is doubling this number here. So if you double that, you get 96. So negative 16t squared plus 96t plus 160. In the very last example, an object is being dropped off a cliff. So the initial velocity, again, is the number in front of the t, right? This number here in front of the t, but there is no t. There is no initial velocity because they're not throwing it off a cliff. They're just dropping it. So the initial velocity here is 0. The initial height is 100 because it's that back term with no variable attached. So it's off a 100-foot cliff. And so since we're not launching this object off the cliff, we're just simply dropping it since the initial velocity is 0. The equation here, we're not really doubling the velocity at all. We're just leaving it the exact same equation here because the initial velocity was 0.